Okay, so if you remember that energy of total energy of hydrogen atom as a function of n and j, that Atul sir derived, right? So that is minus 13.6 by n square. Then you have 1 plus alpha square by n square. Then you have n by j plus half, right? Minus j plus half minus 3. So you can clearly see that total energy of atom after fine structure correction, it depends only upon principal quantum number and total angular momentum, right? Then on questions they others are given. So if you have, let us assume this is your n equals to 3 state and this is your n equals to 2 state. Okay, this is your n equals to 3 state, n equals to 2 state. So if n equals to 2, then L can be either 0 or it can be on, right? So if L equals to 0, then there will be only one state, that is 1 s half, right? You will have only s half. But if L equals to 1, then you have p half as well as you have p3 by 2. So this is for n equals to 2, and for n equals to 3, you have L equals to 0, because L can run from 0 to n minus 1. So this corresponds to j value half. Similarly, for L equals to 1, you will have half and 3 by 2, right? So this is for L equals to 1, and of course then you will have, I'll erase that expression now. So for L equals to 2, you will have two states, that is 3 by 2, 5 by 2. So this corresponds to L equals to 2. And of course L equals to 0 means S, this is P, this is D, this is S, this is P, right? Now we see,
सर L equal to 2 में हम half क्यों नहीं consider कर रहे?
why? Because you see J is how much can run from L plus S to L minus S, right? So
Yes,
if L equals to 2, it means 2 plus half, right? 2 minus half. ठीक है, 2 plus half कितना देगा आपका 5 by 2,
5 by okay okay.
उसके बाद 3 by 2.
और सर
तो
नीचे L is equal to 0 में तो माइनस हाफ भी
नहीं, हमेशा मॉड लेते हैं, एंड ऑफ कोर्स जब S equals to 0, L equals to 0, so there should not be any spin orbit coupling, right? अगर L 0 है तो स्पिन ऑर्बिट कपलिंग होगा ही नहीं, स्प्लिटिंग ही नहीं होगा ना. सेम थिंग हमने जब सेल मॉडल डिस्कस किया था उस टाइम भी मैंने, इफ यू रिमेंबर दैट टाइम आल्सो आई टोल्ड यू, if there is L is 0, then how that spin orbit coupling will come? So if there is no spin orbit coupling, there will not be any splitting. Is it clear, Sautan, what I am saying?
yes,
If L is 0, there will be no spin orbit coupling, right? So that's why there will be not be any splitting. Now if you see that for particular n, for a particular n, so here if you see that n is fixed for all, so for a particular n, the energy depends only upon j. That's why if you see that level of S half is same as level of P half, because for this n is fixed. So what I can say, if I write that state, let us denote A, so I can write this state corresponds to A because it will have same energy. The concept is clear what I am saying, because for a particular n, the energy depends only upon J, and for this state J is same as this state, so they will have identical energy, so I can write the same notation. And similarly same is true for this also, because for this n is fixed, so I can write this state as B, so it will be identical to this state, so their level will be same. And same is true for this 3 by 2 3 by 2, their level will be same because they have same n value. Okay, so let us assume this is your C. Because they are identical, so I have given that notation, because that time when I write the transition, then it will be very clear that why that 5 transition are allowed, but we will only see 7 transition will be allowed, but we can only see that 5 transition. So 2 will be identical. So
Sir,
let's see. Yes.
ये degeneracy है.
Yes, you can say degeneracy because they have same energy,
Same
right?
energy.
Exactly.
Yes,
So from here that concept came. So before, if you don't have any spin orbit coupling, so how many line you can see according to Bohr model? Only one line you can see, right? And that corresponds to H alpha line, right? Because 3 to 2 transition, that is gamma line, and first line that will be H alpha line. But when that high resolution spectroscopy came, or spectrometer microscopy came, so that high resolution microscopy shows that there is not only single line, it will have many lines. So that Atul wrote that transition rule, that is what was that rule? N should not be equal to n prime, right? Delta L should be plus minus 1, and delta J can be
delta J 0 plus minus 1.
plus minus 1. So delta n not equals to n means there will not be any transition among this line. जब जहाँ पे n देखो ये दोनों सेम n है, तो यहाँ पे कोई ट्रांजिशन नहीं हो सकता है. यहाँ पे भी लेवल अलग अलग है, यहाँ पे ट्रांजिशन नहीं हो सकते बिकॉज इनका n सेम है. ठीक है, तो इनके बीच में अगर n डिफरेंट है तो ट्रांजिशन हो सकते हैं. तो इस ट्रांजिशन रूल को लागू करोगे तो देखो यहाँ पे एस इक्वल्स टू 0, यहाँ पे एस इक्वल्स टू पी. ओके, तो यहाँ पे डेल्टा एल प्लस माइनस 1 हो रहा है ना, एस इक्वल्स टू 0, एस इक्वल्स टू पी. सो अगर ए लाइन लिखोगे 1/2 से 3/2, तो यहाँ पे जे कितना हो रहा है, जे का चेंज ऑन हो रहा है, अलाउड है, एल का चेंज भी अलाउड है. ठीक है, सिमिलरली यहाँ से एक ट्रांजिशन यहाँ भी मिलेगा, यहाँ पे जे का चेंज कितना है, 0 है, अलाउड है. ठीक है, और एल तो 1 है. सिमिलरली यहाँ से देखो, यहाँ से आपका यहाँ अलाउड है, यहाँ पे एल का वैल्यू कितना है, 1 है, यहाँ पे 0 है, तो डेल्टा एल सेटिस्फाइड कर रहा है. फिर आपका 3/2 हाफ, तो यहाँ पे भी अलाउड है, राइट, बिकॉज जे का चेंज कितना हो रहा है, 1 हो रहा है. यहाँ से यहाँ अलाउड है, जे का चेंज कितना हो रहा है, 0 हो रहा है, बिकॉज वो है बोथ हैव सेम जे. ओके, सिमिलरली हेयर यू सी, फ्रॉम हेयर टू हेयर इट इज अलाउड 3/2 to 3/2 बिकॉज एल इक्वल
का चेंज 1 हो रहा है.
हाँ, एल का चेंज भी सेटिस्फाइड हो रहा है, जे का भी हो रहा है. यहाँ से आपका एक लाइन यहाँ भी मिलेगा. 5/2 से कितना मिलेगा, 5/2 से सिर्फ आपका 3/2 में अलाउड. तो कितना ट्रांजिशन है, 1 2 3 4 5 6 7 ट्रांजिशन है. बट देखो यहाँ पे देखो आप B2A ट्रांजिशन, B2A ट्रांजिशन, एक ए वाला देखो B2A ट्रांजिशन है ना, और एक आपका इधर देखो ये B2A ट्रांजिशन, दोनों का एनर्जी सेम होगा बिकॉज दैट्स व्हाई आई गिवन दैट नोटेशन, दे आर आइडेंटिकल. सो ये लेवल B है, B से A ट्रांजिशन यहाँ पे है, देखो 1/2 से 1/2, दैट इज B2A ट्रांजिशन. एंड हेयर यू सी 1/2 to 1/2, दिस लेवल इज आई नोटेड B, दिस इज A, सो B2A ट्रांजिशन. तो ये लेवल का जो एनर्जी होगा ए लेवल का सेम होगा, मतलब इस ट्रांजिशन में जो फोटोन का एनर्जी होगा इस ट्रांजिशन में सेम होगा, और यू कैन से दे विल हैव सेम वेवलेंथ. सिमिलरली इफ यू सी another will be same, what will be that, another line will have same energy, which one will be,
C2A.
C2A, this one.
Yes,
C2A,
sir.
how
Yes, sir.
C2A,
सर ये दोनों C2A है ना, ये इधर एक C2A है, L इक्वल टू P स्टेट
3/2 वाले से
हाँ
L equals to 0 वाले पे
इस
Yes,
स्टेट
sir.
को L इक्वल टू 0 स्टेट में C2A जाना जा रहा है ना?
नहीं C2, हाँ ये है, ये आपका C2A है, ये वाला
हाँ
है ना,
ये
और
वाला
आपका C2A है, ठीक है। तो दो चार लाइन, दो यहाँ पे दो लाइन का जो वेवलेंथ सेम है और यहाँ पे दो लाइन का वेवलेंथ सेम है, ठीक है। तो आपका टोटल 7 था, बट यहाँ पे 2 आपका मिस हो जाएगा, तो टोटल लाइन कितना दिखेगा, 5 आपका लाइन दिखेगा, 5 लाइन। तो टोटल ट्रांजिशन कितना है आपका, 7 है, बट यू कैन सी ओनली 5 लाइन्स। But you can clearly notice that you have only one transition, but actually high resolution microscopy or microscope shows there are actually 5 lines. Okay, is it clear?
yes sir
Okay, ठीक। Now Atul sir told you for hydrogen atom how that kinetic energy factor, then you have spin orbit factor play that role. But what about that hydrogen like atom? So I'll give in detail everything. So let me write that total Hamiltonian. So total Hamiltonian of your system will be unperturbed term, that will be H naught. Then you will have kinetic energy term. Okay, then you will have spin orbit term. Then you will have Darwin term. Inside Darwin, or after this all discussion, I'll come to that lamp shift. Okay, that term is very important, and the quantum electrodynamics is there. Okay, in fact, in lamp shift also is there. But let me proceed on by on. So basically, my discussion will be based on hydrogen-like atom, and that is actually important for your exam. So hydrogen-like atom means you did you understand? Like helium plus, lithium double plus, okay, then you have beryllium triple plus, so that they will have high Z, but it will contain only one electron, so there will be factor Z. So let me write one by one. So H kinetic energy, that factor is how much, minus that thing derived, right, P4 by 8 MEQ C square.
a square
Okay, now suppose you have hydrogen like atom, then how much will be that correction? So EKE will be how much? Just you have to take psi, then HKE, of course it will be operator psi, right? So for hydrogen like atom, if you solve it, so it will come minus Me, please be careful, very important factor is there, Me by Me, Me, that is the rest mass of electron, then C square by 2, then you have Z alpha to the power 4 by N4, then N by L plus half minus 3 by 4. So this is for hydrogen atom, hydrogen like atom. So finest alpha is fine structure constant, Z is the atomic number. So what you can infer from here, you have now if you include that kinetic energy, you see kinetic, first message is that the kinetic energy correction actually negative. So you have unperturbed energy level, or you have unperturbed energy level. So if you include that kinetic energy factor, so it will make the downward shift of your level. Suppose you have, I'm giving example, you have suppose ground state of hydrogen atom minus 13.6. So after that inclusion of kinetic energy correction, it will make downward. Okay, it will further decrease that energy. So it can be minus 17 like that. Just a rough example. Another important factor is that
Sir, why sir? ये negative value के लिए negative.
exactly it is negative in sign. You see minus MEC square by 2. You can clearly see that factor itself a negative. So you have earlier energy, let us assume minus 13.6 electron volt. So it will give some minus 0.5 electron volt. Let us assume some rough example. So then your energy will be how much? Minus 16.1, right?
Yes, sir. Yes,
So
ठीक है.
since it is negative, so it will make down. I will write that. Another factor is you can clearly see that kinetic energy correction. So first of all, it is negative. It's a very important message. Second, you can see kinetic energy correction is proportional to what? Z⁴. So that's why I wrote, yesterday I told you. You see, the correction will be very high if for large Z value. But for hydrogen atom, you can clearly see Z is small. So correction will be negligible because this correction depends upon your atomic number. Is it clear what I'm saying? So the important message is that, sorry, here there will be n cube, okay? There will be n cube. N is principal quantum number. So first is correction will be negative. Second, it will be depend upon Z is atomic number. So for hydrogen atom or for lighter element, that correction will be negligible. But if you take heavy element like uranium, polonium, so for that case, that correction will be playing significant role. Another factor is that when if you are increasing that n value, then correction will be small because this is ultimately this will be not n, sorry, this will be n⁴. So if you increase that n value principal quantum number, or if you go to higher state, then that correction will be small. Now I'll give that example. If you have if you understand, then I'll draw that diagram, that it will be clear. So did you get? So kinetic energy, it will be negative, it depends upon Z, and also you can say that it depends upon principal quantum number, that will be 1 by n⁴. Okay, so now can I draw? Is it okay? Puneet, Saudan? Okay, now I'll draw the diagram. So suppose you have initially n equals to 1, hydrogen atom, n equals to 1. So you will have only which state? S state, right? So
Yes, sir.
before kinetic energy correction, it will be like that. But after kinetic energy correction, it will be shifted towards downwards. Okay, so this is after, because n equals to 1 means L equals to 0. Okay, and L equals to 0, so it will shift downward. So now let us assume you have n equals to 2. So it will have two possibility, right? So before applying applying that spin orbit correction or that fine structure correction, there will be only level. But if you include that kinetic energy correction, so there are two possibility. One is for n equals to 2, there will be L equals to 0, that corresponds to S state, and also L equals to 1, that corresponds to P state. Now ये आपका कौन सा स्टेट था? S स्टेट था, राइट? n का वैल्यू कितना था? 1 था. अब इसमें हाँ आपका कुछ शिफ्ट हुआ है डाउनवर्ड, सपोज मान लो यहाँ पे जो आपका S का शिफ्ट है, यहाँ पे n का वैल्यू 2 है तो L का वैल्यू 0 पॉसिबिलिटी है, तो यहाँ पे भी आपका S स्टेट है तो उसका भी शिफ्ट होगा डाउनवर्ड्स की तरफ, राइट? सभी स्टेट फिक्स होंगे, शिफ्ट होंगे, बट मैं पूछ रहा हूँ इसमें जो शिफ्ट है और इसमें शिफ्ट किस में ज्यादा है? आपका ये भी
इक्वल टू 1 पे ज्यादा है.
हाँ, तो ये जो शिफ्ट होगा इसमें भी ज्यादा होगा, बट ये आपका दिस शिफ्ट विल बी, this value will be less as compared to this value because it also depends upon n. For this n is high, so of course that shift will be small because that factor depends upon 1 by n⁴. Okay, and for particular L equals to 0, this state the shift will be high as compared to this. Now what about there is another possibility? This corresponds to L equals to 0 or S state. There is L equals to P, L equals to 1 also, right? So where will be the location? ये जो शिफ्ट L equals to 0 के लिए हुआ है, n equals to 2 के लिए, L equals to 1 के लिए obviously कम होगा. क्यों कम होगा? क्योंकि you can see that n by L plus half, so it also depends upon 1 by L. तो अगर L ज्यादा है तो शिफ्ट क्या होगा? कम होगा. ये आपका फैक्टर था इनसाइड ब्रैकेट n by L plus half minus 3/4. So if you increase that L, of course that kinetic energy correction will be less. So this corresponds to your L equals to 1. So for a particular n, if you increase that L value, then shift will be less. And for particular L, for example, ground state L equals to 0, first excited state L equals to 0. For a particular L, if you increase that principal quantum number, the shift will be less. So that example I have given for ground state S, that shift will be high as compared to first excited state S. Is it clear? Is it clear to all?
Yes, sir.
Yes.
Now you have fine structure correction. That is also for your exam point of view. That is very important. I'll do few problem, but let me give that how that factor is depends upon Z. So if you remember that factor, I am not deriving. So it was how much? E square by 8 pi epsilon naught m square c square by r cube, then L dot S. That was your factor. Adul sir, discuss this part.
Yes, sir.
Okay. Now let us assume this is your A. Let us assume. Then your Hamiltonian will be how much? A L dot S. प्लीज आपको एग्जाम में इस तरह के फॉर्म में ही दिया जाता है, ठीक है, L डॉट एस, और L डॉट एस का वैल्यू भी शायद बोला होगा फॉर्म है ना. सो इट विल बी हाउ मच? A by 2 J square minus
L square minus S square.
J square minus L square minus S square. Okay. Okay. Now it's so energy ESO will be how much? A H cat square by 2 J into J plus 1 minus L into L plus 1 minus S into S plus 1. ठीक है, इतना है. अब सपोज हाँ, no, this is your first form. Eigenvalue of J square is J into J plus 1 H cat square. Eigenvalue of L square is L into L plus 1 H cat square S into S plus 1. Now what I am writing this part, because I'll give that your feeling how that spin orbit coupling used to happen. Now let us take example. Suppose you have hydrogen atom. Let us take first. For n equals to 2, L equals to on, S equals to half. Okay, so for L equals to on, S equals to half. So J can be how much? J can be
3 by 2 and 1
by 2. Now can you calculate for 3 by 2, for J equals to 3 by 2, what will be the ESO? Can you calculate what will be the ESO? How much will be the ESO? How much? So it will be, just you have to substitute.
A by 2 H cat square.
Good. So just you have to substitute.
3 by 4.
No, A by 2 it will be. So A is
So 3 by 4 AH cut square minus 1.
Let me check. So this is your factor. Then J into J plus 1 will be how much? 15 by 4, right? Right? Then you will have L का value कितना है? L का value 1 है. So 1 into 1, it will 1 into 2, it will be 2. Then S is how much? S is half. So half into half plus 1, it will give you 3 by 4. Right? So it will be AH cat square by 2. Then 15 by 4, here you will get 8 minus 8 minus 3. So 15 by 4
Yes.
minus 11 by
3 by 4.
right? Is it clear? Then
Yes, sir.
Yes, sir.
how much you will get?
AH cut square by 2.
Good.
So मैंने half के लिए
Now can you calculate
by
for
minus 3.
good?
So minus 3 by 4 AH cut square.
half के लिए करो आप.
Half के लिए sir minus 3 by 4 AH cut square.
Okay, let me check. J equals to half, L equals to 1, S equals to half. Then ESO will be how much? It will be AH cat square by 2. It will give you how much? 3 by 4, right? Then you have 2 and 3 by 4. So 3 by 4 will be cancelled. So it will give you this 2 minus 2 it will be cancelled, it will
Sir,
be
S is also sir plus half sir. Minus half नहीं होगा sir.
yes, no, S will not be half, S is
Okay,
fixed.
so minus half.
नहीं
Fixed or half?
देखो यहाँ पे स्टूडेंट का मिस्टेक होता है एग्जाम में, एग्जैक्टली
वही सर, वो मेरे को तो
एग्जाम में इसी तरह के क्वेश्चन आप देखना हर साल आता है। एस का कुछ नहीं चेंज करना है, एस इज फिक्स्ड। नाउ व्हाट आई एम राइटिंग, सो दिस पार्ट क्लियर?
Yes, sir.
Okay, now I'll draw this part. So if you draw this part, so which part I will draw for n equals to 2, because ये आपका L equals to non-zero के लिए होता है। तो after adding kinetic energy, your S will be like this, right? Then you have p orbital that will shift less, but after adding spin orbit correction, this will be splitted. So this corresponds to p 3/2, this corresponds to p half. How much will be the separation?
sir 3/2 h का square.
So good. So this half, this part is actually how much? A h cat square by 2, and this part is how much basically? Minus A h cat square, right? So net shift will be how much? This, and this is downward, so you have to add. Did you get? So after adding spin orbit coupling, your P3/2 state will be flip up and P half will flip down. So net will be how much? So ये आपका कितना है? हाफ एच कैट स्क्वायर, ये कितना है? माइनस हाफ एच कैट स्क्वायर, तो ये कितना हो जाएगा टोटल स्प्लिटिंग कितना हो जाएगा ये वाला?
3/2 h cat square.
A h cat square by 2 plus A h cat square. So it will be 3/2 A h cat square. Okay. So like that, the every term used to come. Now, if you write that A is not constant, now if you write that ESO, so now I am not writing in terms of A. So just give that how that splitting used to happen and how much will be the separation between two levels. That is very important for your exam. Now in normal form, the energy will be how much in terms of Z? If you calculate, that will be how much? So it will be basically me c की power c square by 4, then you have z alpha to the power 4 by n cube j into j plus 1 minus L into L plus 1. You can write capital L also, okay, minus S into S plus 1. Then you have factor, that is L plus half, L plus 1. Okay, this is your correction. So there are two possibilities, either J equals to L plus half. Here it depends upon J.
A naught cube भी क्या डिनोमिनेटर में होगा?
हाँ?
A naught cube भी क्या डिनोमिनेटर में होगा?
A naught cube?
Yes sir.
A naught cube?
नहीं उसके वजह से अल्फा आ गया ना.
अल्फा आ गया ना उसमें.
Okay. Yes sir.
J equals to L plus हाफ के लिए कितना हो जाएगा ये फैक्टर? बताओ. ये आपका सिंपली हो जाएगा me c square by 2, then you will have factor z alpha to the power 4, this factor will be 4, then n cube 1 by 2 L plus half into L. So me c square by 2 z alpha, this power is 4 by n cube 2 L plus half into L. Okay, and what about your L minus, for J equals to L minus half, it will be how much? So energy correction for J equals to L minus half, so it will come me c square by 2, then you will have z alpha to the power 4 by n cube on by 2 L plus half then L. So we can clearly see that spin orbit amount of splitting, it depends upon Z. Amount of splitting is depends upon what factor? Z n. I'll give that example. इतना लिख लिया आप लोगों ने?
सर ये
Yes, sir.
एम
Yes,
क्यूब
sir.
के नीचे क्या है, नीचे वाला?
ये वाला
ये सर
n क्यूब के बाद ऑन बाई 2 इंटू एल प्लस हाफ इंटू एल, ऑन बाई 2 एल. Okay, sorry, this factor here you will have minus sign for j equals to L minus half, you will have minus sign, and this is not actually 2, this is 4, and this is also 4, but for j equals to L plus half you will have plus sign, but for j equals to L minus half you will have minus sign. Okay, but important message is that spin orbit splitting ESO depends upon atomic number z to the power 4, and also it depends upon principal quantum number as 1 by n cube, 1 by n cube. Okay, is it clear? Now I'll give
Yes, sir.
So for a particular n value, it depends upon z की power 4. Suppose आपको दिया है एग्जाम में, सपोज मान लो कि let me write on example, then it will be clear. हाँ, सपोज मान लो आपका हाइड्रोजन का 2p3y2 और 2p हाफ इन स्टेट का 2 मतलब यहाँ पे 2 मतलब प्रिंसिपल क्वांटम नंबर, 2p3y2 योर टर्म, 2p हाफ, इनका स्प्लिटिंग गिवन है. स्प्लिटिंग कितना है? 0.365 सेमी इनवर्स. ओके, अब पूछा गया है कि हीलियम प्लस का सेम स्टेट means fixed n here, this is actually n value, 2p 3y2 and 2p half, इनका स्प्लिटिंग कितना होगा? So here you can clearly see 2 is here 2 means n equals to 2 प्रिंसिपल क्वांटम नंबर. So p3y2 and p के बीच में जो सेपरेशन है वो कितना है? हाइड्रोजन एटम के लिए कितना है आपका? 0.365 सेमी इनवर्स. आपको पूछा गया है हीलियम का कितना होगा फॉर सेम n एंड फॉर सेम l. सो हाउ इट विल बिहेव? सो यू कैन क्लियरली राइट ESO फॉर
Yes.
helium divided by ESO for hydrogen. It will be depends upon Z helium divided by Z hydrogen to the power 4, right? So it means splitting of helium will be 16 times splitting of hydrogen, and that value is given, that is basically 0.365 semi inverse. So how much it will be? 5.84 semi inverse. ठीक है, तो क्लियर है ये? इसका मतलब क्या है? सपोज मान लो आपका हाइड्रोजन का 2p स्टेट n इक्वल्स टू 2, स्टेट का जो p3/2 p हाफ, इनका सेपरेशन कितना है? 0.365. ठीक है, अब सेम स्टेट का अगर हीलियम का देखोगे, हीलियम के लिए आपका हाइड्रोजन है, हीलियम के लिए अगर देखोगे सेम स्टेट का n इक्वल्स टू 2 का, n इक्वल्स टू 2 के लिए जो p3/2 और p हाफ का जो सेपरेशन है वो इस तरह से इतना लार्ज हो जाएगा, ये 3/2 ये हाफ, ये आपका सेपरेशन इतना लार्ज हो गया। ठीक है, ये कितना है 5.84। ठीक है
यस सर।
जितनी
यस सर।
शायद आप लोगों का क्लास बहुत छोटा हो गया। ठीक है, कल करते हैं इसको अच्छे से, सर अभी तो शुरुआत ही हुआ है। ठीक है, तो अभी आप लोगों का क्लास है ना?
यस सर।
ठीक है फिर कल।
सर
ठीक है,
ओके सर, थैंक यू।
ओके।
थैंक यू सर।